moving on. 393, 1 through 30, nope, 41 to 71. Maybe. 41 to 71 odd. All right. So 393. You're so excited for that. All right, I'll solve some of the even numbered ones, and you guys get to solve the odds. I'm sorry. Okay, so number 42. Log base 2 of the quantity 3x minus 1 equals 3. How would you solve this? Oh, good. How? 42. We're looking at 42. So maybe let me remind you of something. In a logarithm equation, there are 3 different places to put the variable. So let's say I had log base 2 of x equals 4, or I could have log base x of 9 equals 2, or I could have log base 2 of 16 equals x. Those are the 3 options. Either the exponent is in the logarithm, it's in the base, or it's the answer. And this one is the easiest. X is already by itself. So how do I calculate that? Change of base formula. ln 16 over the ln of 2. So if your exponent is over here to the side, just use the change of base formula and figure out what it equals. It's just asking for the exponent. 2 to what power is 16? The answer is... That was the problem I wrote. I just made it up. So that one's easy to solve. What if this is what you're looking at? The variable is inside the log. How do you bring it out? You can't divide by the log. You convert to exponents. 2 to the 4th equals x, which happens to be 16. Okay. What about if the base is missing? Convert to exponent again. X squared equals 9, so x is, or, now negative 3 creates problems, and Cynthia probably just wants 3, but we never know what Cynthia wants. What Cynthia wants, Cynthia gets. So, you looked at her picture and you think she lives in the city? Look at that. She looks like a city slicker. Okay, number 42. How are we going to solve 42? Come on, guys. Pay attention. 42. 2 to the 3rd equals 3x minus 1. This is just 27. So you would add 1 and divide by 3. So you're going to get 28 thirds. Oh, I don't know what I'm doing. 2 to the 3rd is 8. Add 1 is 9. Divide by 3 is 3. There we go. I was just seeing if you're paying attention. Okay, 44. Same idea. 4 raised to the negative 2 equals 5 minus 2x. So that's 1 over 16. You're going to subtract 5 and divide by negative 2. That's pretty simple. 46 is a little bit harder. No. The only time you can drop logarithms is if you have one logarithm on one side and one on the other side and nothing else. So if we had log base 6 of x squared equals log base 6 of 36, then I can cancel the logarithms and just take the square root. But if there's anything else attached to it, that won't work. So for 46, I need to combine these using the product rule. If you have two positive logarithms of the same base, you combine them into one. So it would be log base 10 of x to the third equals 3. Now what? Convert to exponent. 10 to the third equals x to the third. So the answer is 10. Okay, look at 48. Same idea here. Going to combine them into one logarithm base 2. So log base 2 of x minus 1 times x minus 3 equals 3. No, I wish you could. If this was on the other side and there was no 3, you could. So you're only allowed to drop logarithms if that's all you have. One logarithm equals another logarithm. So 2 to the third equals x squared minus 4x plus 3. And this is 8, so I'm going to subtract 8. And I get x squared minus 4x minus 5. Factor that into x minus 5 and x minus 1. So x equals 5, or plus 1, and negative 1. And you probably want to double check to make sure that that works. So 5, if I plug in 5, am I okay? If you plug in 5, you end up with 4 and 2. That's fine. But if I plug in 1, am I okay? Plug in 1, you get log base 2 of 0, which doesn't exist. And log base 2 of, it's negative, oh, so negative 2, that's still a problem. And then negative 4. So this answer doesn't actually work. Whenever you're dealing with logarithms, you have to plug your answers back in to make sure that you didn't create any negative logs, because they don't exist. Remember, the graph of a logarithm looks like this. So there are no negative numbers in its domain. All right, 50. Okay, 50 we can actually drop logarithms once we make a change. So I'm going to combine these using the product rule. Log base 2 of x plus 1 times 4 minus x equals log base 2 of 6x. And now I have a log on each side. They have the same base, and there's nothing else out there. So I can cancel those. And this is going to give me negative x squared minus 1 plus 4. So plus 3x plus 4 equals 6x. So I'm going to move everything over to the right. X squared minus 9x. Oh, did I do that wrong? Oh, that's a positive 6. And minus 4. Okay, thanks. So plus 3x minus 4. Factor that. X plus 4 and x minus 1. So my roots are -4 and 1, and then I need to double check. Is that going to create any problems? What were we doing? 50? So -4, I cannot plug into either one of those. I mean, actually, you need the 3, so that doesn't work. And 1 is okay. So the -4 is not an answer, but 1 is. Okay, 52 is the same. Combine using the product rule. What about 54? Not the product rule, quotient rule. So log base 3 of 7 minus 2x over x plus 2 is equal to 2. Now I only have a logarithm on one side, so I need to convert to exponent. So 3 squared is equal to 7 minus 2x over x plus 2. So this is a 9. I'm going to multiply that to the other side, and I need to remember, anytime you remove a variable from the denominator, you have to restrict your domain. So if -2 is one of my answers, I'm not allowed to use it. So 9x plus 18 equals 7 minus 2x. Add that 2x back over. 11x, subtract the 18. That would be 9. No. Oh. 11. Oh, it's 11. -11. So x equals -1. So now I have to look back at, what problem are we doing? 54. So I just need to double check, is -1 going to be a problem? That would be 7 plus 2 is 9, that's okay. And that would be -1 plus 2, which is 1, that's also okay. So x equals -1 is the answer. All right, look at 58. So this will be log base 2 of x plus 1 times x plus 5 over 2x plus 5 equals 2. So we're going to end up with 2 squared is equal to x plus 1 times x plus 5. And I'm going to multiply the 2x plus 5 to the other side, remembering x is not allowed to be -5/2. So 4 times 2x plus 5 is equal to x squared plus 6x plus 5. Just distribute the 4 and move it to the other side and factor it. Yeah, it shouldn't be too bad. Okay, now the next set, it says solve the logarithm equations exactly and then approximate your answer. So we're assuming that none of these are going to factor. So let's take 62 for instance. So I'm going to have 10 squared equals x squared plus 4. So 100, and I'm going to subtract 4. 96 equals x squared. I take the square root, and I get x equals plus or minus the square root of 96, which is 4 times 24. 4 and 24, 4 and 6. 2, 2, 2, 2, 2, 3. I can pull out 2 sets of 2s with a 12 left over. Oh, 2 times 3, sorry, with a 6 left over. So 4 plus or minus 4 root 6. But I need to look back at the original. Am I okay plugging in positive and negative numbers in there? Yes, because the squared is going to get rid of them, so both answers are valid. Okay, 68. ln of, I'm going to multiply these together. 8x squared plus, nope, 4x squared plus 8x. 68 equals 2. What is the base of the ln? E. And you guys finally have a purpose for E, that continually compounding interest. The best definition of E comes in calculus, which some of you will get to later. So in this case, E squared is equal to 4x squared plus 8x. Oh, that's cruel. That really isn't very good. So I'm going to subtract E squared. So 0 equals 4x squared plus 8x plus E squared. Minus E squared. E squared is an irrational number. So am I going to make the problem any worse by dividing by 4? No, so let's go ahead and divide by 4. X squared plus 2x plus E squared fourths. Now they might do something crazy like this on the final. So your final will be partially multiple choice and then partially free response. So how would you solve that exactly? The calculator will give you a decimal approximate. How would you solve it exactly? Just go with the decimal and hope you get enough credit. What you should do is plug it into the quadratic formula, and it wants an exact answer. It doesn't say a simplified exact answer. And in fact, if you simplify and make a mistake, you won't get the credit you deserve. So you would do -2 plus or minus the square root of 4 minus, so it's going to be 4 times 1 times E squared fourths. So the 4's cancel. So 4 minus E squared. Oh, guess what? E is 2.7. Does anybody see, have I made a mistake anywhere? I don't think so. Oh, dang it. I was hoping it was imaginary and we could stop. So that changes it to 4 plus E squared over 2. Now this is the answer. And in fact, you can't simplify it anymore. So even if it would simplify, if you were doing this on the final, that is the exact answer. It might not be the most simple form of the exact answer, but it is an exact answer. And then instead of evaluating that, I would graph it and get the decimal approximate out of your calculator. That's way easier. But it ended up being easier than I thought it was. I thought we would have to do a lot more simplifying, but okay. So on 71, you're going to get ln of x plus 4 over x minus 2. All of that is raised to the 1/2 equal to ln of x plus 1 to the 1/2. What would you do from there? Drop the ln's and nope. Drop the 1/2. Now you can drop them in two different ways. You could pull it down here and pull it down here, in which case you drop the 1/2 and the ln at the same time. Or you drop the ln's and you say this quantity to the 1/2 is equal to that quantity to the 1/2. So these two quantities must be the same, and you drop the 1/2 as an exponent. Okay, so 71 might look tough, but it actually works out to be pretty easy. And that's it. You don't have to do the applications and the catch the mistakes. Sorry, Jason. I know you're looking forward to it. Hey, good luck.